All right, so let's answer all of these questions. Okay. Now, what I want to do is I want to actually stand on the ground and watch this proton go to the east. So I'm looking north. And if I look north, I would see this. And it's got to be a downward electric field. So that means that what? The positive plate is on the top and the negative plate is on the bottom. Okay. And we've got this guy flying through there. And when it's in there, when it's inside there, we know that the electric force, which is EQ, right, that's going to be down, and we know that the magnetic force, the QVB, is going to be up, right? Furthermore, we know that the, oh, it doesn't ask that, okay, good enough. All right. Sometimes they ask about like the separation of the plates, right? And the electric field is just the voltage divided by that distance between the plates, right? There's a minus sign that we ignore. So anyway, let's look at this, right? If the proton were to speed up, which way would it deflect? Well, the electric force is unchanged by velocity. It only depends on the electric field and the charge, and neither one of those change. But the magnetic force is changed, it depends on the velocity. So if you speed up, the magnetic force is going to be bigger. So if you speed up, it's going to deflect this way. It's going to be a little parabola. If it slows down, well, then they're not equal anymore, right? This gets less than this, so it's going to go this way, right? If you slow down, it's going to deflect down, right? What if we decrease the magnetic field? Well, if we decrease the magnetic field, this electric field stays the same strength, so it's going to deflect downward, right? Because this guy is going to be stronger. If you decrease this guy, if they're equal and you decrease the magnetic field, this becomes less than this. So it's going to deflect downward. And then if you increase the magnetic field, of course, it'll deflect upward because now this force, upward force, is bigger, right? If the electric field is increased, you deflect downward because the downward force depends on the electric field, and this does not. And if you decrease the electric field, then this force would be then stronger, so it would deflect up. Right? And then neither one of these forces depends on the mass of the particle. Right? Gravity is probably inconsequential as far. These forces are probably 15 orders of magnitude larger than gravity. And then, of course, we know that that's not going to change the trajectory of it. The mass doesn't change the trajectory. So in this case, the mass has no effect either way. All right.